Hey guys, Adam Savage here at my cave with another chapter in the Samaritan build saga. Today's chapter is the trigger guard, which was super fun to cut out and sculpt and adjust to look right. The rear sight, which was a pretty simple thing, and the latch, the latching mechanism, which allows you to load it and unload it. That kicked my butt. That was maybe the most difficult part of this build because I am, as I've said many times, I'm what you'd call an aesthetic machinist. I'm really good at making stuff look like it should work and look mechanical and look shiny and precise and stuff like that. But when it comes to machining stuff where the mechanics have to work, that is less of my expertise. And in this, the mechanics are diabolical. You've got a hinge down here, and then you've got a frame that comes up here, and you have another frame that comes up here. There are like multiple parts. There's all these elements that have to come into concert with each other to dance correctly so that that latches. I can't tell you how many times I screwed this up and ultimately how much I learned doing this, including learning that I was capable of machining something of that level of precision and complexity. Let's get into it. There are sometimes some things I have to work out off camera. That's just a fact of making stuff. Not everything, but there are really specific times when I'm working on a specific problem to solve and I don't know exactly what I'm doing. And look, not knowing exactly what I'm doing is really specifically my brand, but still, this is such an involved build with so many interdependent parts and pieces that I have been sort of moving apace at my own pace, filming the important stuff. And please, even though this looks like it's highly almost done, it is so not almost done. There is a lot still to do to make this puppy work. There is a lot. A lot. Yeah. But the very next thing I am going to complete on this is the closure. So I have it so that it opens, and that's the correct angle. That's how it opens in the film. And I'm really pleased with all of the orientations. I have been in touch with my friends at Weta Workshop, and lo, halfway through my build, I managed to obtain some correct size. Some actual engineering drawings. Hey, how about that? I mean, look, there's a few things better than having an original, an actual, and I've got the stunt pistol that I've been working off of, but still the engineering drawings help. So the closure is a fairly involved little bit of engineering because there is a little bridge that comes out across the top of this, and this gets machined out, and then there is a pin. You'll understand this all as I go. But there's a pin here, and the closure actually clamps and moves the pin as it comes in and locks. So it basically, to close it, you do this, and to open it, there's this little arm here, and you go, and that gets you the release from the locking mechanism. So to release it, you push that little button here, and it opens up. Next stage of this guy is that it's time to make it close. Right. First up, I've got to machine out this part of the back of the gun correctly because on the real one, oh yeah, here you go. Okay, here's the stunt pistol, which I've opened up. You can see on the real one, the back of the gun is machined out. I've got to do the same thing on this one before I do anything else. So here is, you can see this. Now this is the stunt pistol, so this is all made of resin and rubber. But what you can see is there's a pin. Where is it? It looks like this. See, it's got these two 15-degree, oh, there we go. It's got these two 15-degree slots in it. And what happens is that this sits in here like this, and it's pinned into this little, that's rubber, but the real one is, whoop, the real one is metal like that, okay. And then when you bring the top down, and I can't do it because of the way the stunt pistol is built, it takes a little maneuvering, but you can see that there's this part, this I don't know what to call it. Anyway, there's this part that comes down over that pin right there. It'll all be super crystal clear as I go. The next step for me is to machine out that bit. So I'm going to take the gun apart a little bit in order to have access to that. Parts management is a deal with builds this complex. I mean, just holding on to all the bits and pieces is non-trivial. The backplate is drawn bigger in the engineering drawing than it is in the actual one. I'm going to follow the actual one. So what I need to do is, I need to do that. So let me get a little bit of marking fluid on here. On the gun body as well, because that's the next thing I'm going to machine after this. And I'll be marking it up so I know that my machining is good. I'll also have to drill this hole through the top. Yeah, all right. Successfully notched out, glinting in the sun. I've successfully notched out this back plate. It is structurally slightly different than the screen used back plate. As you can see, so understand, in order to fit in all the trigger mechanics, and I haven't even cut the hole for the trigger guard. I haven't even started on those parts, but I needed to hog out all of this part of the back gun part in order to fit the mechanics, because this will be a true double action pistol, which means that you could pull the trigger and the hammer comes back, cocks, and you keep pulling the trigger, boom, and it fires. Now, this isn't going to be a firing gun. It's made out of aluminum, but I've pulled a ton of weight out. I think that my completely aluminum Samaritan is actually going to end up being lighter than the stunt ones, which kind of makes sense, actually. Because I've held the real one. Guillermo del Toro owns it, and I've seen it at Bleak House more than once and held it. And I just don't remember it being spectacularly heavy like my stunt pistol is. Okay, so there's just a little bit of ugliness there. I'll need to address that. I may actually just tap in a little plate there with some 256 screws. But the next thing is to mark out and hog out this part right here. It has been a long day. My back is sore. I've been at this for 7.5 hours now without a break. I mean, I walked the dog, but here's what I got. Confession time. Here's what I got. My fellow soldiers would tell you I'm a terrible shot. That's not true. But I have made this bracket piece, which is literally most of my time today. And here is, see how tight it is there? Look at that. Very little tolerance. And the last bit of doing the inside of this piece was done with a file on my stitching pony. Yeah, here's the time lapse of it. There is a way in which to get two parts. I mean, understand the geometry of this starts here, and all of these pieces were made centered and according to the measurements and everything, but still, no matter how tight you are with all of your persuasions, when you get to a pair of things that have to marry each other like that, and they got to go back to the same location, you want some adjustability. That's all I'm saying. This is what I have learned. I am someone who is given to slightly too high a tolerance. I cut too close to the line and then I have to wiggle around it. But in this, only a file, not a mill, would have taken me that last bit. Yeah, I know I could CNC, but I'm just not interested in that. But frankly, that's the most satisfying thing that's yet happened on this build. That is crazy. I'm super chuffed about that. Oh, I guess I should show you. And this might be a whole separate video, but the lore of the Samaritan is that it's made from pieces of religious artifacts and that its handle, its grip is made from pieces of the true cross, the cross that Jesus was crucified on. Anyway, the true cross is made, I looked it up, out of pine and cypress and cedar. So I purchased some chunks of all of those things. Pine, I don't want to use it. This is cypress. It's like pine. It's too lightweight. But I did make myself a sample handle here. There we go. So we can see. Now we can see that things are happening. Hold on. Let's see. I can wait. Oh, yeah, here we go. Oh, look at this. Oh. Ladies and gentlemen. I don't want to get optimistic here. There is still a lot of work to do on this. I got to do the front side, got to do the rear side, got to drill and tap the holes that attach that in. I got to, oh man, I got to put in the little bronze remover, and I got to mill sorry, I know I'm bouncing all over the place, but that rod I showed you earlier with the 15-degree cuts in it, it's totally wrong. The problem is that these engineerings I got are slightly off. And that's totally to be expected. You never know at what point in the production an engineering drawing gets made, especially in film. I wanted to state that the original gun, and I said this at the, have I done the top of this video? The original gun was built by an amazing model maker named Dominic Taylor and Jamie Neville. And those two had a month to make two hero guns with the speed loaders and all of the different bullets. That is a tight time schedule. I am like 2 full person weeks into this, and I'm not close to done. And I'm not having to build working speed loaders, and I'm also doing the bullets, but I'm taking my time. So it was Dominic Taylor that sent me the engineering drawings, but they're not exactly right. They're not there of a moment, right? But when the thing gets built, remember how I said like just a minute ago how you really want some adjustability in this. That as they were building these guns, they made changes, they made modifications, and that's totally that. That certainly happens, especially with a director like Guillermo who likes to improvise. Right? He sees something he likes, he wants to go towards it. You got to be ready for that. With every director, man, there's like, yeah, you can't get attached to anything. Anyway. Today, progress was made, and I am pleased. I am very, very, I mean, that might be some of the more exacting engineering I have achieved in terms of a big honking thing. Still a long time away from being able to hold this thing. All right. Okay. Our Samaritan proceeds apace. The next thing I'm going to make is this little bit right here, the trigger guard. Now, I have a trigger guard that I cut off of, or I removed from, I think, Sideshow's all metal Samaritan, which is a lovely prop replica. But I also have an engineering drawing. And so I cut that engineering drawing out, and I pasted it to this big chunky chunk of aluminum. And we are going to spend some time cutting this out. It's going to take a while, but that's the next phase, cutting out a trigger guard. I'm starting out by drilling some holes around the cut. When I've got an engineering drawing attached to this piece of aluminum, I don't want to use a lot of cooling fluid when I do this. And cutting, it's going to get hot. So I'm going to cut some relief holes using the drill press to make my job a little easier. Okay, so I've drilled a bunch of holes. There's the trigger guard hidden among all those holes. Now, the other reason that I have drilled all these holes around this is there are shops that do a lot of aluminum work where they've got some really nice saws with cooling fluid and all that dedicated to cutting thick aluminum. I don't have such a thing. I've got my nice wood bandsaw with an expensive blade on it, and I don't want to overtax that blade. My tools are all general purpose. And that means that for cutting out something big and heavy like this piece of aluminum, I want to go carefully. And if I overtax my bandsaw blade, it's a $40 blade, I got to go buy another one. So anyway, the holes are a way to sort of take some of the heavy lifting off of a lot of my my cutting tools. I know this looks rough and tumble, but frankly, unless you have a dedicated saw for aluminum with cooling fluid and all that, this is the best way for me to creep up to this paper template and make sure I'm getting exactly the form factor that I want. I am now going to start to do some sanding on this. Look, this is me not being too greedy about how much material I want to take away. I know that out of a piece of wood, I could cut this trigger out in like 4 minutes, and it's very much in my nature to want the same thing out of aluminum, but I have to go slowly. So that's what I am doing. I'm pleased with how this is going. So now we're going to do some sanding, and I'm going to pull out the spindle sander for the interior part. Yeah, the spindle sander that I recently built into a thing underneath my table saw. Yeah. My trigger guard profile is now completely cut out and sanded smooth. I've gotten rid of all the saw witness marks. Yeah. I'll get that. As I was saying, my trigger guard profile has been cut out. I have not finessed the attachment to the pistol. Hold on. That's the next step. That's the next step, is to make those two mating surfaces as tight as I can. I'm going to make them super tight, and then I'm going to, actually, it's already pretty close. But what I'm going to do is I'm going to get them really tight, and then I'm going to cut this thing to width, and then I'm going to do the final shaping. I have found that if you do all your shaping and your polishing and then you do the fitment, it's a bad way to go, because I might need to hold on to this with pliers, with something. I don't want to make a finished surface that I'm going to mar. I want to actually get everything kind of like working together, and then, only then will I do the final polishing. All right, here we go, to the sander. Touchy little operation. Yeah. All right. Yeah. So you can see the mating surfaces are pretty good. Got just a tiny bit more adjustment, but for the most part, yeah, that's it. I'm really, that is fantastic. All right. So next step is to cut this to width. Oh, hi, I was recording. Okay, so here's where I am right now. I have marked out, I think you can see here, the marks for the internal thinness, and then it's the full fatness out here. So this little mark across the way is my slant to the ultimate thinness. Again, I am sort of taking, how do I say this? I'm attacking each dimension individually. I've made trigger guards before where you started trying to round them out and then trying to get them in the right shape, and it's a nightmare. So I'm doing everything square right now. And then once I have my critical dimensions, the fatness, the transition to the thinness, then I'll start to round this. Then I'll take it to its final sanding at a 400, and then I'll polish it. Actually, before I polish it, I will attach it to the gun so I make sure I have perfect fitment, and I'll drill and tap 2 holes here and here, and we'll be good. I think this deserves a time lapse. And also, I'm wearing the full face shield because I need to get my eyes really right up and close to where I'm working. So I got this nice piece. All right. Trigger guard is most of the way there in terms of its form factor and its critical dimensions. Sorry. Hi, there I am. So now it's time, I think, to tap it and install it onto the gun, and then I'll do its final shaping. 1.32 minus 0.61 equals, divided by 2 equals 0.355. I'm making sure that I'm tapping the holes dead center of this thing and in the meat of the trigger. This isn't the way the real trigger is attached. The real gun is actually built somewhat differently than this, but 1.32 divided by 2 equals 0.66. I always forget that. I am, yeah, it's a longer piece to camera about the difference between the two guns, 0.66. There we go. So that is nice. Nice. Lovely. Lovely. Chamfer those holes. Then what I want to do is I want to clamp in this guy. This is a really important operation. I want to get this exactly right. Come on. Good. Now I want to put a piece of tape on here so I don't go too deep. That is the depth I like. All right, let's get some cutting fluid on there. Now, just to make sure I don't accidentally torque this, I'm also going, oh, wow. Can I even reach that? Oh, you know what? I'm going to have to do a pilot hole there with a tiny long drill. Okay, so here's the thing. Like when you're drilling a hole like this and you're clamped in place, just think about what it's like if you lose your position. So you want to start both holes. That's the goal. Don't second guess your mark. Go right to your mark. Okay, so I'm happy with that. I'm going to unclamp it. Wow, yeah, it's for real. Okay, good. The farther you get down the path with any specific piece that you're making, means that if you mess it up, you have a longer way to go to recover. So that means that the farther you go, the slower you go. So it's something to like remember when you're doing really work that is precise, is those last few steps often take as long as the first does. The last two steps might take as long as the first dozen because of exactly that. And there we go, ladies and gentlemen. Yeah. So, trigger guard is in. The gun successfully latches and unlatches. There's not video of me working this relationship out because it took me an entire day and I kind of needed to not be filming while I figured that out, but it's really nice. And it took... Let's just say it took all my skill. But that's not what I'm here to talk about. I'm here to talk about this, the trigger guard, which I'm really pleased is mounted in. Still needs a little bit of final finessing in terms of how it marries to the pistol. But we are super, super close. And I'm going to take a break right now and enjoy the furtherance. We've got a trigger to make, got a hammer to make, rear sight, front sight. And then we're like, oh, yeah. And then this handle, the base, and the emblems. We're moving along.
my finished trigger guard. And I actually drilled a central hole over here. And then I realized that part of the trigger mechanics have to go past that. So I made 2 more holes. That was a 632 in the middle. These are 2 440s. And that should hold this nicely on the gun. I've gone and polished it, but I didn't need to because I'm actually going to paint this whole thing matte black. But yeah, that was like 4.5 hours, 5 hours of work to get this one piece done. But I'm really pleased with how it looks. It is tight as a drum on the gun. It looks exactly like the original. I blew through here in the hole, but I fixed it with a little crazy glue. Yeah, there's one trigger guard. It's lovely. The gun continues to proceed. As you can see, I'm sort of going hell-bent for leather on this. It's such a satisfying project. And there are so many moving parts to it. But, wait, no, I didn't. Okay, good. But this one is a fast one. Hey, this one's a faster bit of the build. There are 3 main pieces of the gun's body left to construct. The hammer, which was a cast bronze or white metal part for the original. The trigger, which was hand-built out of brass, and the top sight. I am going to build them in reverse order, and I hope to complete them today, all 3 of those, but you never know. I'm going to start with the top sight because that's a quickie. And I know I like to say I like to begin with the most difficult one. With mechanical problem solving that might take me a huge amount of time, like the hammer, I like to start off with something that's like a palette cleanser. So I'm going to jump into the top sight because that'll be a fairly straightforward bit of construction. And once I've completed that, then I'm going to move on to either the trigger or the hammer. I'm not sure which. It might be the hammer. We'll see. But top sight coming up. Like I said, the original maker of this gun, Dominic Taylor and Jamie Neville, Dominic has been in correspondence with me, sending me pictures of the original build. It's been super awesome and crazy important in helping me get this build across the line. In addition, he sent me some of the original engineering drawings, but they don't all match. They don't all match this pistol, which is the one of the stunt pistols. This is cast from Dominic's build. This is a cast piece from the aluminum build. Oh, so in that case, instead of following engineering drawings, I'm following this. This is what was used in the films. This is what I'm going to follow. So I'm about to take the measurements on the top sight here. Oh my God, there's so much to sort. Oh well, I'll just go with these calipers. Or 285. The original gun was built in millimeters. Mine is not. 1.3185. 0.27. F.27. And they're both slightly different sizes. Oh, but you've got a screw at the bottom of you. Look at that. Oh, a little flathead screw. That is going to be a 256. So this is actually a square slot, and it goes to this. Oh, right. And that's the measurement I want to get. What is this? I think it's 0.25. G, 0.25. D, question mark, C. Oh, is the same as I because I already had it, 0.98. Okay, This is the piece I'm replicating. As you can see, it's got a square slot in the middle with, I only noticed for the first time, little flathead screw holding it down. I was wondering how this was held down to the piece. It's got these radius end mill cut 3 sides. Notice that the 2 halves of the sight are not exactly even with each other, and I think I'm going to make mine even. You know, the sort of thing that sometimes happens in production. But yeah, I'm going to make this piece, and then I'm going to probably polish it to get some of that rounding that you can see on it. Yeah, and then install it. I'm going to set out to do some layout on this piece of 1/4-inch aluminum. You can cut in Adam using a blow dryer in the distance sound there. Okay, so A, 0.4285. Now, I got to figure out what radius this cut is, because it's a fairly big radius. It is a fairly big radius. I'm not sure I have the end mill for it, but I might. I ended up purchasing what is this? A 1-inch radius end mill to cut these guys, because those are a 1-inch radius. In the end, I actually borrowed a 1-inch radius router bit from my neighbor. And this came after I made that cut. But I have this radius, so I think it might be, hey, it is. See, this is the thing. You got to think like a model maker. The model maker is like, oh, I want a big radius on that. Let's pull out the biggest one I've got. 1 inch. That's what it is. That's great. There is my piece. Notice I've left a little relief on the 2 cut sides there and there so that I can machine them back to perfection, and then I'll do the final cutting on it. Well, it turned out that the radius end mill I bought has a shaft too big to fit into any of my R8 cullets. I'm going to have to machine a special holder for it. So I used a 1-inch radius end mill, and it worked out quite nicely. I've got quite a nice radius. My corners go to the corner, give or take a thou or two. Now I just need to cut the middle slot here. Yeah, and then make that slot, drill the hole for a 248 slotted screw, and we're almost there. here is my top sight. I may need to do a little secondary pin to mount it to the back of my gun. But here is the back of the gun, and here's where it mounts. That in focus? There we go. All right, so time to mount it to the back of the latch assembly. Okay.
It's time for the trigger. I have printed out an engineering drawing of the trigger. Yes. And yeah, there's some interesting geometry here. Yeah, I'm going to fabricate this completely out of brass. So here we go. Yeah. I have the brass for my trigger cut out. I have drilled the two critical holes, the pivot hole and the activator hole. And now I'm going to start making it shaped like a trigger. I'm going to round this, and then I've got to take a ball end mill and hog out a whole bunch of the back of this trigger. If you want to look at the original, here you can see, yeah, there you go. Here you can see the back, and from what I understand, they manufactured these, they made these by hand. So I'm going to do the same. I'm going to keep this thing close by for reference, and I'm going to do a lot of this shaping. I'm going to do a lot of this shaping. Oh, I see. I'm going to do a lot of this shaping. Yeah. It's just going to be a lot of the shaping is going to happen here on the spindle sander, but I may go away to do some work on the, yeah, you know, it's all of a piece. There we go. That is the main body of the trigger. And now I'm going to put some marking fluid on the back and use a ball end mill to start hogging out the back of that. Yeah. Well, it's only about an hour later, and I am most of the, there we go. Come on, focus. Thank you. I'm most of the way there on the trigger. I've hogged out the back. I've
just drilled a 16th inch hole here for the linkage mechanics. I'll probably expand that hole later, but for right now, I don't need to. I am going to, let's see, I am going to shave this a little closer because it is almost time to place this. I'm going to do some more hogging in here with a Dremel, not a Dremel, but the Proxxon little spinny tool. And then I'm going to put a, yeah, I think I'm going to hit this on the Scotch-Brite wheel, and we'll be ready to polish it up and maybe even install it in the gun. What? Trigger is in. It clears the the cylinder just barely. I still have a little work to do on that. I got the rear sight on. The latching mechanism is a thing of beauty. Oh, this is still a temporary handle. Time to make the hammer.
A couple things about the build you just witnessed. One is the cylinder rotation. Now, this cylinder is a very heavy item, and its rotational inertia is significant. So as you move it around, it rotates. Well, that won't do for a movie weapon. And in the film, Weta Workshop had a mechanical stop for the cylinder, which is I'm at this point positive that's beyond my capabilities. But I came up with what I thought was a pretty clever idea, which was there was these 4 holes here in the leaves of the top of the cylinder. And I put a magnet in each one, and I put a pair of magnets behind this strike plate back here. Now, when I was tumbling these parts, one of those magnets came loose. It came loose from the crazy glue that was holding it on. And I thought, oh, well, in this assembly, I'll just tape it in. It doesn't need to be precise. It's just keeping this thing from rolling, right? It's like, yeah, you can see it. Each time you bring the cylinder in, it holds it there, which is awesome. But the fact that I didn't hard glue that magnet in gave me this extra bit of awesome in this build, and it's this. Dude, seriously. If you asked me to put that click in, I'd be like, I'm not sure how to do it. And you'd come up with a little ratchet and a little voice box and a little thing. And it's just, no. All you needed was a magnet. And I learned that by accident. And it's maybe one of my favorite discoveries in building this gun. Thank you guys for watching. I'll see you next time. Thanks for watching that video. If you want to support us, one of the best ways you can do it is going to our merch store and purchasing one of our beautiful new posters. This one right here is called Elevations of Bear. And this is a compendium of 16 pages from my sketchbook when I was actively building my bear costume for San Diego Comic-Con a few years ago. What did I do with a bear costume at Comic-Con? I dragged around the carcass of Leo DiCaprio, reversing things. Now, this might be enough information for you to build your own bear costume, or you could just frame it and hang it in your house. Each poster is printed on a really lovely tactile heavy cardstock. Get your own by following the links below.